In this video, we're looking at a very interesting limit which has a certain significance to it and inherent importance to it, which I will talk about at the very end. I am Mr. Ish. Thank you for joining me. Let's look here. Limit as x approaches infinity, e to the power of x divided by x to the power of n. These are powers of x, a function which represents powers of x where the n represents positive integers. You know it won't be fractional values, but it will be values such as 1, 2, 3, 4, on and on, even in odd exponents. If you evaluate this, put infinity in places of x, you are looking at an infinity divided by infinity indeterminate limit form, for which you can attempt the L'Hopital rule. Now the problem is, no matter how many rounds you do, for the numerator it'll always be e to the x and you'll always end up with an infinity. In the denominator, this will eventually exhaust towards some sort of finite value, and then you can put an infinity. And think about it, if you have something like x cubed as a denominator function, you know the first order derivative is 3x squared, you do another one, you're getting 6x, you do another round, you're getting a 6. Eventually it always makes its way towards a finite value. The numerator, however, does not. The end result of this limit is infinity. Now, what is the significance of that end result? It's actually quite interesting. The limit outcome tells us very clearly when you're looking at exponential functions, it will tend towards infinity much faster than those functions which represent powers of x. This will eventually make its way towards infinity but slower. And think about it. The exponential function will look something like this. It will tend towards infinity in terms of the range much faster than these powers of x, where the n represents positive integers. You know what that would be. X to the 1 would be a linear function, x squared and the even functions would be like quadratic variants, cubes and odd functions would be cubic style functions, but these will all end towards infinity slower than an exponential function. Now when you combine this video with the previous video where we had a limit evaluation involving the natural log and the powers of x, we can talk about things like this: the logarithmic x versus the powers of x versus the exponential. In terms of approaching towards infinity, this is much faster than this and this right here at the very end. So this is an important overall lesson for us to know. Thank you for joining me. Have a good day. Bye.